Google had failed in translating many languages, especially Japanese. So in this video, I'm just going to be talking about the evolution of Google Translate, how it got from a trashy machine where it couldn't translate even a single sentence, and now today it is translating millions of languages, millions of text every single day, and helping people into translating languages and connecting people overall in understanding each other more better, and just helping other people to connect the world which we live in today. So take this video as a constructive criticism, not as a hate video. Take this as an informative video for you guys to learn how actually machines and languages were interacting, and people, they really worked hard to make these two uncompatible things compatible with each other. And today, in this whole world of ChatGPT and large learning models in AI, we are surrounded by human languages and machines trying to understand human languages, and humans trying to understand how these machines actually are working. Also, in this video, I'm going to be recommending you guys on which translation tool is the best for you, and especially for Japanese, because it's the language which I've learned for over 6 years now. And so in my experience, which is the best Japanese translator for your next trip to Japan. So stick around. Okay, I know that you didn't wake up today dying to learn how machine translation work. And I get it. Maths, algorithms, neural networks sounds like something out of science fiction movie, right? But no jargons, no brains. I'm just gonna explain you simply how machine translation work and how are machines interacting with the human languages in a simple way. Did you know it all started with war? Let's dive into the timeline. The surprising history of machine translation. During World War II, decoding enemy messages wasn't just helpful, it was life and death. This pressure sparked the first real attempts to build machines that could understand and translate language. It wasn't about tourists, it was about survival. And there comes this man, Alan Turing.
What? I don't speak German.
How the hell are you supposed to decrypt German communications if you don't, I don't know, speak German?
Well, I'm really quite excellent at crossword puzzles.
That's right, he did not speak German. And that might have got you wondering, how can someone not knowing the language know a language? And moreover, crack an encrypted code in that language? You see, Alan was great at patterns, and computers are also kind of like Alan. They actually don't know the language itself. However, they can understand puzzles and patterns. And languages are just like a pattern recognition game. For example, if you tell a machine, in this following sentence, I go to school, where I is the subject, go is the verb, and school is the object. Similarly, in Japanese, the object comes before the verb. And this is another rule which you can make a machine understand. Now, the problem which both computers and Alan had to face was languages has millions of rules and millions of words. So actually, when we talk about machines trying to understand human language, it's just the history of machines evolving over time to understand the rules and patterns in each human language. And of course, machines did not start their understanding of languages from heavy German or Russian. That's a lot to handle for a machine. They started with something simple, English. It had a simpler script, and also the grammar is fairly easier than others. Their goal is simple: create a machine, or let's just call that machine an artificial brain, which can understand and translate human languages. So in our quest of creating an artificial brain, in 1954, the Georgetown IBM experiment happened. It was the first public demo of machine translation from English to Russian. Or in other words, US telling to its people that we have created a brain which can translate into Russian for us. Why? Well, the US wasn't too happy about the Soviet Union showing off in space and tech. The Cold War was in full swing. Yeah, another war moment. This machine translated just 60 sentences. And people were like, wow, by 1960s, machine will do all the translations. But of course, language has many words, not just 60 sentences. Things are just starting to begin. Our artificial brain is just born. But we're in 1960s now, and here comes the big boy. Cistern. During 1960s to 1990s, a rule-based system like Cistern took over. And this is where our accuracy in translation will take a jump. Our artificial brain is starting to learn. It worked on massive dictionaries and a truckload of grammar rules. Sounds smart, right? But here's the catch. One tiny error in the input, and the output, absolute chaos. Looking at the translations, even aliens would say, what is this? Now we're in the new century, where statistical revolution happened. Machines started learning from big data. It was phrase-based statistical machine translation, or SMT. It relied on phrases, frequency statistics, and alignment models between parallel corpora, like the UN documents. Words or phrases were translated based on probability, not just semantic similarity. But this was just a game of probability. They used math, but not the serious math. They even referred to it as Google Translate Beta. Beta is the label in software, typically means that the product is still under active development. It may have bugs and may not be fully reliable yet. And things did not change for many years. Time went by. Google and other translation tools used statistical machine translation for most of their work. Major upgrade. There's this new thing in market called as AI and neural networks. You know why some people are concerned about AI taking over? This is because these are scary intelligent machines. Let's just focus our attention to text data and text translation. This new version is called as Neural Machine Translation, NMT. Google switched to using AI now. Now the inputted text is converted into vectors, that is numbers. And the machines know the relation between all those words by playing some serious math. Also, these machines are trained on huge data. I mean really huge. Like the GPT-3 model, it was trained on 45 terabytes of data, which includes almost all public websites. They are called as transformer models. Yeah, not that Transformers, buddy. Now, instead of translating word by word, or comparing it with the document text and then using probability to provide the output text, it looked at whole sentences at once, paying attention to each word in the sentence and its relation to other. Then by comparing it with the huge data it is trained on, this makes the translations way more natural. For instance, set the table versus set of sticks. The machine knows which set you're actually referring to. This is when things got way better for languages like Japanese and Korean, where relation of each word to each other is so important. Suddenly, the beta label was gone. Moreover, in 2019, a new concept of zero-shot translation and LLM made things even better. Google Translate learned to translate between two languages it wasn't directly trained on. For example, it could go from Spanish to Japanese, even if it had never seen that pair before, by using English as a bridge in its AI brain. Transformer models are really cool. So yeah, basically all the ChatGPT and AI bots which you use today are born because of translation. Added features like live camera translation, offline translation, and real-time conversation mode. Even YouTube videos now have an audio language option. Seriously. Billions of pages, billions of users, and suddenly we weren't just translating Shakespeare. We were translating memes, tweets, and anime subtitles. And now YouTube videos. Modern machine translation isn't just about language anymore. It's about context, culture, speed, and even slangs. Okay, so now you know the history behind machine translations, Google Translate, and other AI models, and also ChatGPT. So what's your takeaway? This is just showing the evolution of machines trying to understand human languages. Our words, the words which we speak from our mouth, and this is just our effort to make that machine understand what we are trying to speak. So you know, all these cool AI models which you see around today, they are basically made for understanding and comprehending human language, and not just language. They're also there for comprehending our culture, our nuances, our jokes, and our daily life. And that is how they're going to affect our daily life. They're going to help in our daily life. And that is all the motive which is happening behind all the AI tools which are using today. So when you see the history of machine translation, you can see the fact that Google Translate had a lot of difficulties at the start. Most of the languages which were supported had a beta label. So that means that most of the languages which were in a beta mark were not fully accurate with their translations. And when you see at the beta labeled languages, you can see that they are mostly non-Western languages, or let's say they're non-European languages, they're mostly Asian languages, or let's say languages which are mostly were spoken in Asia. And there is a reason for that. First reason is culture. The second reason is availability of text data. And what do I mean by text data is availability of digitized text data. You see, back in 2000, there was not much digitized text available for Japanese, or let's say all those beta label languages. And that was the main concern. And that also meant that even if they have the UN documents, those document data was not sufficient enough. Those text data was not digitized, and that was not on the internet. Of course, it was written on paper. There was a lot of data which was available on paper. But to digitize that, we need to have fonts. You need to have PDF documents of those, because we are trying to make the machine understand a language. So we need to have a digitized text data, like other languages had an ample amount of data. Like for instance, English or French. And so, you know, the beta label was actually removed for most of the languages. And of course, the last language to have that beta label removed was Japanese. And again, this is a factor which I think influences the translation of Japanese really a lot. There are already so many well-researched videos about how the internet is different between the East and the West. And they're right, it's completely different. They're completely two different worlds. Western internet feels like walking into a sleek, minimalistic Apple store. Eastern internet, sometimes it feels like clicking through 5 neon pop-ups just to find the login button. But why? Well, it's not just about design choices. It's culture, it's history, and it is how internet evolved in this both part of the world. Okay, so I'm just gonna explain you with an example, okay? So the books here in Japan, they're totally different. When I came here, I was really shocked. But it's in the culture. I have a book here, and when you see in this book, is that it's so much information, so much colors, and so much information cluttered in. And when you see at this book, you might think like it's, oh my god, it's so colorful and so different. But it is how manga culture, or let's just say Japanese culture, has evolved. And Japanese people like things like they are here. So I don't see it as a abnormal thing, because for them, it's a normal thing.
Even the menus here are so different.
Now let's just try to understand why I think culture plays an important role while translating Japanese. Here's a clinic website and timetable. You want to reserve your appointment in your neighborhood. But you see something strange. Why there is a fire, water, tree, and wish written in this website? Someone with zero kanji and Japanese knowledge might start scratching their heads. See, when you use Google Translate to translate website or scan using Lens, it's just translating the OCR recognized text. It doesn't know if this kanji, he, means fire or Tuesday. In this context, it's written on a timetable, so it should mean Tuesday, not fire. Here's another example. Server, can I have the check? Google messes it up completely. First by calling the server Saba-san, which is so unnatural, and the following, O kaike o itadakemasu ka? It conveys the right meaning, but the translation is still not natural enough. Now when we switch to ChatGPT, as expected, it's spot on. In fact, when we see the usage of Google Translate around the world, it comes second behind the United States, which is obvious because Japan being the popular tourist destination and the cultural superpower, which drives many people to this country. But it's the only popular destination where English is not so much integrated into the society. Now let's talk about something interesting. Tourism. Let's zoom into Japan. So what happens? You land at Narita, you're tired, you're hungry, you just want to get to your hotel, but there is nobody surrounding you who can speak English and who can guide you. So instinctively, you just open up your phone and you tap on the most familiar blue icon, which happens to be Google Translate. Okay, so now you know the reasons and factors why Google was so bad at translating Japanese. But the real question is, what is the best translation tool for you? Well, it depends on your purpose. If you need a quick, reliable, real-life translations while traveling, and you have a stable internet connections, tools like ChatGPT, Gemini, and other AI models are nearly perfect. They sound natural. It's like having an interpreter in your pocket. But don't forget tools like Google Translate, deepl, and Google Lens, especially when you're out in remote areas where there's a low connectivity and you don't have enough data on you. And you can translate any menu in a restaurant using Google Lens. But again, I would recommend AI models because they are flawless, their context awareness, their natural tone, it's so great that, of course, it beats Google Translate or deepl in any sense. Okay, so now we're done with the video. You can leave the video, but there's one more important thing I really need to talk about. I'm a human interpreter. I have worked with government-level interpretations, and I've learned one thing. Translation isn't just about converting words. It's about translating culture, emotion, and humor. It's about creating a connection between people who don't share a language. One of my favorite Japanese interpreters, Miho Hashimoto, said this beautifully in her TED Talk. I'll link it below so you can see what I mean by translating culture.
I could use an AI voiceover for my videos, but the lip syncing would sound weird.
But this voice makes you connect to me as a human to human. This voice has this potential, this power. And that is what I'm trying to say when I'm trying to say translating culture is, translating humor is, translating emotion is. AI can help us translate words, maybe even culture, but it won't be able to do things what humans are really meant to do.
Our laughs, our emotions, our jokes.
This was my goal for 5 though.